let's say we want to find the area under this curve. This is y is equal to fx, or let's say just fx here. So one way to do it is if we form few rectangles here like this, and then so rectangles will go like this, then again like this, then like this. So this could go a little bit more here, and then maybe like that. So all these rectangles, let's say this is x1, x2 and so on, and all these rectangles area of the rectangles are uh, calculated and then summed up. We will get approximately the area under the curve, though it's not quite right because there are some overestimation and underestimation. As we can see, this is underestimation here, and at some places this is underestimation, and some places this is overestimation. Anyway, so this way it can be written like area of the first one. If we say this one, so let's call the middle point here, the ordinate is, let's say, alpha 1 here. So the area will be f alpha 1, which is the ordinate, times the, if this is x1 minus a, that is the this part, which is the abscissa of. So this is the first rectangle. Then the second rectangle will be f alpha 2 times x2 minus x1, and so on it will go, and then finally it will be summed up. So if I sum up, it will be like this. Let's say k here from 1 to n, and we have f alpha k and x k minus x k minus 1, like that. So that is the total area if we sum it up. But to make it more accurate, if we can take the rectangles to be smaller and more number of rectangles, so basically the difference x1 minus a, similarly x2 minus x1, if these differences can be made to be smaller, so let's call this difference, let's write it first, n here, and f alpha k, and let's call it del x k. So if this del x can be made to be very small, how small? Very small, then we will have a better approximation. And if we can make this del x to be infinity, so if we can make as such that limit del x tends to infinity, sorry, not del x tends to 0 basically. So let's say like this, if n tends to infinity, and then we have the same summation, k is equal to 1, from k is equal to 1 to n, and we have f alpha k and del x k, but this will go up to infinity, so infinity number of basically rectangles. Or otherwise stated, if we can make the del x to be very small, del x tends to 0, if we can make that, then this one equals to the integration fx dx. This is the definition of integration. So that's what we do when we integrate a graph.